Hi everyone, myself Janendras, pursuing BE in SVC. I welcome you to my presentation, and my topic is environmental impact of an underground pipeline. Assessing environmental impact, a case study on pollutant concentration in underground pipeline. Assessing environmental impact is crucial for understanding how pollutants affects ecosystem. This presentation focuses on a case study involving pollutant concentration in underground pipelines, highlighting the methodology, finding and implement implications of environmental health. Introduction to environmental impact of an underground pipeline. Soil disruption. Installing pipeline often involves digging trenches, which distributes the natural soil structure and can lead to erosion or compaction. Water pollution. There is a risk of leaks or spills during the construction or operation of pipeline. This can contaminate nearby water bodies, harming aquatic life and impacting drinking water sources. Habitat destruction. Building pipeline can disrupt local ecosystems, sometimes requiring the removal of trees or other vegetation, which can harm the flora and fauna in the area. Emission of greenhouse gases. Even though pipelines are designed to be efficient, there can still be emission from the transportation process, and leaks can release methane, a potent greenhouse gas. Risk of spills. Accidents can happen leading to the soil or gas spills that can cause extensive environmental damage, including long-term effect on the soil and water quality. Noise and air pollution. Construction and maintenance activities can produce noise and air pollution affecting local wildlife and nearby communities. Cultural and social impact. The installation of pipeline can disrupt communities, particularly if it runs through indigenous lands or areas of cultural significance. Methodology overview. This case study employed a multifaceted methodology including field sampling, laboratory analysis, and data modeling. These methods helped in accurately assessing pollutant concentration levels and their potential environmental impacts. Various sampling techniques were utilized to collect data from different pipeline location. Techniques included graph sampling and composite sampling to ensure comprehensive coverage and accurate representation of pollutant levels. Laboratory analysis. Samples were analyzed using advanced laboratory techniques such as gases, chromatography, and mass spectrometry. These methods provide precise measurement of pollutant concentration, allowing for effective risk assessment. Data modeling approaches. Data modeling was performed to predict pollutant dispersion and assesses potential environmental impact. Models integrated geographical data and pollutant characteristics to simulate real-world scenarios and outcomes. Key finding. The study revealed significant pollutant concentration near certain pipeline sections, indicating potential environmental risks. Identifying these hotspots is essential for developing targeted mitigation strategies to reduce contamination. Implication for policy. Finding from the case study highlights the need for enhanced regularity framework and monitoring programs. Policymakers must prioritize the management of underground pipeline to mitigate environmental risk effectively. Mitigation strategies. Effective mitigation strategies includes regular monitoring, immediate leak detection, and the use of bioremediation technique. Implementing these strategies can significantly reduce the environmental impact of underground pipeline. Future research direction. Future research should focus on long-term monitoring and the development of innovative technologies for pollutant detection. Collaboration between researchers, policymakers, and industry stakeholders is essential for effective environmental management. Conclusion. Wrapping up the environmental impact of underground pipeline, here are the main takeaways. Soil and water destruction, disturbance from digging and the risk of pollution from leaks, habitat and ecosystem damage, threats to local flora and fauna due to habitat destruction, greenhouse gas emission, potential methane leaks and transportation emission, spill risk, possibility of accident leading to severe environmental consequences, noise and air pollution, impact from construction and maintenance activities, cultural and social effects, disruption of communities, especially in sensitive areas. Thank you.